analyzing the specification of the leave management system. Okay. And I hope the presentation is visible now. Okay. And just to form a structured approach to analyze the natural language specification, we are doing some linguistic processing and deduction on the specification. The first, what we did is we identified different nouns and categorized them, clustered them, and so on. And also, identified from the nouns as to which are the nouns which merely are used as values. They do not have actions on them, as so they qualify as attributes and so on, and did a quality check. And based on that, we have identified a possible set of classes that this design is going to have. Then we started exploring the responsibilities that these classes will have. So to identify the responsibilities, we need to focus on various actions that the classes can take. For example, what are the operations that can be performed by a certain object of a class, and keep some view in terms of reusability and extendability of this, which events are expected, and so on and so forth. What objects will react to those events, and so forth. So we performed a linguistic analysis of different verbs, because verbs typically will designate the actions as noted. So in blue here, we identify the different verbs, and of course we do some semantic reasoning on it. For example, a verb like company wants. This verb wants is not something which will get into the design, because it is a mere way of doing the specification, right? Whereas employees work, report to lead, apply for leave, approve, leads approve or regret leave, and so on. These are verbs which necessarily relate to actions. And we also saw this example of identification of verbs in terms of different leave components, leave types that are specified. And we collected the list of identified verbs and noted that since verbs can exist in different derived forms, we need to do a stemming to really extract verbs which are primary. And after stemming, these are the verbs that we have. We have like regret, credit, check, adjust, club, and so on. Okay. So now we try to relate from the specification, we try to relate the classes as identified and the verbs that we have now extracted. So which classes are for every class, what are the verbs or what are the actions, the responsibilities that will be entailed? For example, a employee works, records attendance, requests for leave, cancels leave, can approve leave, and so on, if the employee is a lead or manager. Similarly, for a casual leave class, we have responsibilities as crediting of leave, prorating of leave, approval of leave, and so on and so forth. Okay. So we relate the classes with the verbs or the responsibilities, and also do some marking if the verbs apply to all people or all objects, or they could be selective. Of course, there is a typo. What will also have to be blue, because these are responsibilities which all employees will do, whereas some responsibilities like approve, regret, or report are limited to some of the employees, and we'll see how to make use of this information subsequently. So like we did for the concepts of classes, we also do a abstraction for these responsibilities or actions. So there are key actions like report, request, approve, and so on. And there are non-key or supporting actions like can be clubbed and so on. And there are some auxiliary actions. Okay? So we have also tried to identify we have the classes now with their attributes and their responsibilities. Right? So you can loosely you can start to see that we are slowly going towards a more typical C++ kind of class design, where you have attributes which will eventually become data members, and you have responsibilities which will eventually become member functions, right? So it's like for employee, these are some of the attributes and these are the responsibilities. Similar thing can be done for executive, lead, manager, and so on. Similarly, for the leave classes, we have attributes like type of leave, the start date, duration, and so on. And we have responsibilities like whether the leave is valid, whether it is accounted for, and so on. So you can complete this for all the types of leave classes that you have. So with this, certainly our sufficiency is now slowly increasing. So it was unclear, but now some sufficiency is coming in place, some completeness is also improving. So we can check. So now, up to this point in the analysis, we have classes identified, we have attributes identified, we have actions identified, and we have a fair understanding about the attributes of different classes and responsibilities or actions for different classes. But they are all like they are all isolated in this. They're all they're like a pool of classes giving rise to a pool of objects. We really need to concretize in terms of how they interact, how they get associated. Right? So the next action required to improve on this is to explore the association. So let us go there. There are a lot of. So now what we are trying to do is we know the classes, attributes, and responsibilities, and we will try to identify the possible collaborations between the classes, the modularization of the design, and identification of the hierarchy. So this is what we are going to do next. So we have already analyzed the responsibilities. We want to see the relationship and hierarchy between the classes. Right? We do 3 steps. Identify the possible relationships or collaborations between classes. For those relationships, we try to describe the nature of the relationship. And we identify the hierarchy between related classes. These are the classes, just for handy list. These are some of the attributes. These are attributes and responsibilities of classes we have already seen for employee, for leave, and we have seen. Okay, now collaborations. The class company which is of organization type, has a responsibility to manage. Right? Company has a, it's more like an abstract concept of collaboration. So who all would company collaborate with? The collaborators are employees and leave. So that the two entities that we are talking of here. If we talk about employees in general, then some of the responsibilities are record daily attendance, request for leave, and employees have to collaborate with leave, right, for the leave management system to work. Of course, employee will collaborate with themselves, which is trivial and not important. Now, if you have the specific executive class, then that will collaborate with the leave as well as with lead, because executives have to report to the lead, ask for leave approval and so on. Lead similarly will collaborate with the leave, with executive, with manager. Manager will have to do that similarly. Manager will also have to collaborate with the sysadmin. Leave has to collaborate with employee in the other direction. So right. So these are grossly we can identify from the description that these are the kind of collaborations that must exist in the design. These are some more examples of collaboration which are trivial for the different leave classes. Of course, the responsibilities may be different because different leave has different kind of actions required. So if we try to modularize this whole concept, then we can see that three major cohesive subsystems are emerging from this. That's, I mean, the best of collaborations will clearly tell you that company has employees who apply for leave, right? In very simple terms at the top level. So three main modular decomposition come out of this, that I need to have the model of a company which has employees, and employees apply for leave. Again, the measures, certainly the primitiveness is slowly improving, the completeness is also improving, and so on. And cohesion really has become high now because collaborations and all that are already set out. So with that, we go to the next target, that what is the hierarchy? Now, this hierarchy is kind of extracted from two factors. One is the commonality of attributes. Right? As you have seen in the basic definition of inheritance in C++, certainly a generic class in the hierarchy will have common attributes, which should apply to all the subclasses. Whereas subclasses will have their, respective additional attributes. Similarly, the generic class will have the common responsibilities, and the subclasses will have either refinement of the common responsibilities or new responsibilities added. Right? So this is the first level of hierarchy that we can think of is I have a concept employee, which is a generic class, and three subclasses: executive, lead, and manager. That right? We further can see that between these subclasses also there is a kind of hierarchy. Right? Because the lead, whatever the executive can do, the lead can do that and does something more. Whatever the lead can do, manager can do that. and does something more. So we also say that this is not a very flat hierarchy, but it is kind of manager is a lead, is a executive. So with that, we come to this kind of a hierarchy diagram, which later on we'll see that this actually is a UML form of a diagram. So which says that manager is a lead. This arrow with a blank triangle head means is a manager is a lead. Lead is an executive, and executive is an employee. Now, in this, finally, employee is more of an abstract concept because everyone has to be an employee. So it's more an abstract concept which holds the whole thing together. So we write that this is abstract. And we also mark some of the collaboration actions. For example, the executive request leave report to lead, lead request leave reports to manager, and these are the possible leave approvals that can happen. So this is the basic hierarchy diagram. We are slowly, you can see that we had a pool of classes. Now we have found out the coupling between them. Let's move on. So this is what we have. Now, coming to the leave, we have all these 1, 2, 3, 4, 5, 6, 8 kinds of leave. And certainly, at the root, we have again an abstract concept of a leave which certainly the abstract concept will have attributes like the start date, like the employee ID, like the duration and so on. Whereas various specific properties will be held by these leaves. Now, we got a hierarchy, but this hierarchy is rather wide. There are too many specializations, and it is shallow. Right? You just want that hierarchy. So which means that if there are commonalities between these different leaves, we will not be able to make use of that in terms of our design organization, code organization. So from this arises the need to identify possibly some intangible concepts which can balance this hierarchy. So let's see what these could be. So let's say at this point, to refine the hierarchy, we do a kind of precondition, postcondition analysis. What is a precondition? A precondition is something that will hold before a leave is kind of initiated. And a postcondition is what will hold after a leave is availed, right? Or in the process of the leave. So if you have, say, if we talk about, so what are the properties? Again, these properties will be extracted from the combination of verbs and nouns that we have already identified. So one property is entitlement. That am I entitled to certain leave? So he'll say yes, 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 mostly yes. And there are some qualifiers. For example, for a duty leave, there is no entitlement for a duty leave. The company will assign you and then you will go for duty. So there's no concept of entitlement. For a medical leave, the qualifier is it is applicable only for female employees. It is applicable when that employee is pregnant, and the company puts a condition that it can be availed only twice in her career in the company. Similarly, for unauthorized leave, it is the deemed entitlement for a week before the action starts. Right? So you allow for a week, you allow the unauthorized leave to continue. After that, you act. Then you have duration of leave, which are properties which are kind of yes mean that there is a well-defined duration, whereas for unauthorized leave, you have a qualifier that it is allowed for up to 7 days, but it's not a very hard and fast. Then you have additional properties like is the leave clubbable? We had seen while discussing that well, casual leave may not be clubbed with any other leave, whereas an earned leave can be clubbed with other leaves other than that casual leave. So we say if the leave clubbable, casual leave is no, earned leave is yes, sick leave is yes, and so on. Is the holiday exempted in the leave? It is exempted for the casual leave. Is the pre-approval necessary? It is necessary for the earned leave or for a medical leave, but may have certain exemptions where the pre-approval is not necessary. For example, for a sick leave, exception condition for sickness. You may not, I mean, there may be planned hospitalization also, but it may be just unplanned sickness or exceptions for parenthood and so on. Then the carryover and accumulation properties. Does it carry over? Casual leave does not carry over. Maternity leave does not carry over and so on. Whereas earned leave and sick leave do carry over. Can the leave be encashed? You have in earned leave can be encashed, nothing else. Does the leave need certification? Yes. Sick leave need, medical leave need, parental leave need. Is the leave paid? Yes, except for the leave without pay and the unauthorized leave. You get paid during the time you are on. So these are, I mean, earlier we have identified most of these as attributes of leave. Now we are trying to see what are the possible values these attributes can take for different kinds of leave. And according to the commonality of possible values, could we group the leaves into certain, abstract leave subclasses? Right? So here is the analysis, and here is what we are trying to do. So let's say, let's take something, say, is the leave paid? Two cases say that it is not paid. So based on this row, I can, group the leaves in terms of certain subcategory of leave where no payment is allowed. I call it a no pay leave. This is an intangible entity in the sense that the specification has not told you anything about a no pay leave. But specification has told you this is how the leaves will behave. But according to that, I can say that no pay leave has a property that payment will not be made. So therefore, in the system, it will have repercussions that, the monthly salary processing for such cases will not be permitted. And LWP and unauthorized leave fall in that category. Right? So they are specialization of no pay. Does the leave need certification? Again, 3 cases need certification, others don't. So we can subcategorize based on certification. So these are, we say, is an abstract concept of certified leave. PL, ML, SL are certified. Do they carry forward and accumulate? EL and SL do. So I have a carry forward concept. SL and EL fall into that. Should it be pre-approved? The EL, ML, LWP must be pre-approved. So these are the remaining don't need to be pre-approved. So the concept is presented in the negated form. That is, no pre-application is required for CL, PL, or SL. Right? Is it clubbable? EL and SL, only CL and UL are not clubbable. So you can see that everything else is a specialization of clubbable. EL is encashable and so on. And you further see that this column DL is not applicable for all of this. So it is kind of falls in a different category altogether. And therefore, every other kind of leave has a commonality which is separate from what is duty. So I extract another abstract concept, non-duty leave. And all of these intangibles that we have identified fall under the non-duty leave. And then it is a duty leave. And then it's so you can see that in this in this way, if you check, then we achieve a couple of things. One is we have a multi-level hierarchy, which is more balanced, and we have a number of intangible concepts for leaves identified, which will subsequently help us to apply that particular I should say, whether strategy or rule for that particular type of intangible concept. So you can easily understand that these all intermediate subclasses are basically going to be kind of abstract classes, right? Because but each of such abstract class will inherit from the parent the common properties, and it will have certain specific aspect on which it will put the rules. So which makes it, otherwise if in a flat one, then you just do not know if CL can be on duty. Right? There is no way to enforce that. You'll have to write separate condition checks in your code to do that. But here, the hierarchy itself brings in the whole situation in terms of the basic structure in which the leaves are presented. Right? So we have a much better hierarchy now. So naturally, we have improved significantly in terms of the coupling. We have defined for employee and leave. We have defined the proper hierarchy and coupling for that. We have moved towards completeness, and we have identified all different or a major part of the different primitive classes that will be required. Right? So these are, in terms of the relationship, these are the relationships already identified. And now we present a diagram through which we can put the relationships in a very concrete manner. This is just not an arbitrary drawing that I'm doing. This is the very first kind of UML diagram, which is known as the use case diagram. So what all does it have? You can see that there is a boundary here drawn on this. with a banner which I've kept blank. And there are certain items outside this boundary. So the use case diagram's interpretation is this bounding rectangle is your system. So whatever you have inside is what is happening inside the system. And what you have outside, these human-like figures and this printer, these are external to the system. Right? This is again something which is not explicitly written in the specification, but you will certainly understand from the specification. So what are these external items? These are called actors. In the UML terminology of use case diagram, these are called actors. So actors, like executive is an actor, lead is an actor, manager is an actor. Actor could be human, actor could be non-human also. Right? Actor could be active, like executive, lead, manager. An actor is active if that actor can initiate actions. Whereas an actor is passive if the actor participates in an action but cannot initiate an action, like a printer can print on a printer. Right? I could have shown another non-human active actor like sysadmin. I have not. Now, within the box, if you come inside the box now, rectangle now, this is the world of the system that you are going to build. And what all have you captured? All these ellipses are known as use cases. That is, they talk about the individual specific ways that the actors take action and use the system for. So let's look at an executive. So what the executive use cases of the executive are the primary actions that the executive would like to do, like approve. I think there is a problem of that the request leave should be here. So there's a little problem in this diagram. So actually this should be executive. This should be lead. But the specialization arrows there are specialization arrows. That manager is a lead is an executive. But this association of actions, there is something little wrong here. So think about this as an executive. Ignore the specialization arrows. So what an executive can do, can record daily attendance. That's a use case. The executive can request for a leave. The executive can cancel a leave. The executive can avail a leave. An executive can export a leave. That is, a report of what all leave the executive has. I read this as an executive. Now this is a lead. So lead is an executive. So lead is an executive. Tell us this. Arrow has to be reversed. Lead is an executive. Tell us that the lead can do all the actions or have all the use cases that the executive has. So this being a lead can do a daily attendance, request leave, and so on. But in addition, Am I audible?
Yes, sir.
Okay. It looked like I got disconnected. Now, and ignore this specialization arrow. Think about the manager is a lead. So manager is a lead means the manager can do the special use cases of the executive, of the lead. It can do the use cases of the executive. In addition, the manager has some use cases which is exclusively for the manager. Like it can, the manager debit leave, can adjust leave, it can manager can produce performance report, can credit leave and so on. Right? So that's a basic, basic information about the use cases, actors and use cases. Right? Now, there are some more things to look for here. For example, if you look at the export leave and export executive leave, you see a arrow which looks like specialization. Is it? That is true. That is, use cases can also be specialization. One use case could be a specialization of another. So what is this use case? Export leave is to export the leave of one employee. What is export executive leave? Is exporting the leave of an employee, but the use case is driven by a different employee. Okay? So this basically is same as the export leave, but it is a specialization of that. Because to do export leave, you do not have to say who the employee is, because whoever is the executive can get his or her own export. But to do export executive leave, the lead or the manager has to specify which particular executive is being talked of. So this is a specialization of the use case. That is, the use cases could also be on a hierarchy, so that one use case does achieve something, and the specialized use case achieves that and does something more. Then there are dotted arrows from use cases to the printer. The printer is an actor, which is a passive actor. So a dotted arrow from a use case to an actor means that this actor participates in this use case. A solid arrow, I mean not dotted arrow, a dotted link takes part. But a solid link will mean that the actor initiates the use case. Right. So actually, you can see it's a diagram, but it is like it is pretty much like a, a language. So UML is a graphical language. So we are trying to, so every symbol used here is not arbitrary. It's not just for the sake of drawing. Everything has a meaning. And therefore, once all that you have explored, you are putting them in this kind of a UML diagram. You are in one diagram, you are saying a lot of things which otherwise would have required pages of writing and ambiguities and so on. Okay, let's see the other things. You have a dotted arrow from request leave to check leave. Check leave is a use case by itself. The executive can go and check what is the leave. That's absolutely. But request leave is another use case, that is requesting for the leave. Now, what will have to happen? According to the specification, you can request for a leave only if the will not be able to request. So the request leave use case necessarily have to check the leave for satisfying the request leave. Right? So that property of use cases is being marked by this dotted arrow, and by the side you have a gullimets. Gullimets are very widely used in the UML diagrams, a guillemot is written in terms of a pair of corner brackets, angular brackets. Less than, include, greater than. So include means the request use case will include the checklist use case. So you can see how nicely the concepts are getting concretely captured in terms of a small diagram. Then you have a look at this credit use case. Right. Credit use case can be acted upon by the manager. Right. It does the credit. Now, you say that the extension point is new joining, something which is not directly modeled here. The use cases of joining, bringing in a new employee is not modeled in this diagram. So you say that's an extension point. It's like kind of an external event which triggers certain credit actions. So you perform those credit actions when a new joining happens. So this particular use case has one possibility that manager initiates it. The other is that this initiation is necessary when you have a new joining. That's the extension point. Then you have performance report, and you have another dotted arrow to credit with a guillemot extend. This does not, include says that this use case has to be done as a part of the bigger use case. But extend says that after doing this use case performance report, you could extend it by crediting certain leaves. So this is, I have not yet formally introduced use case diagrams, but just took the opportunity to use this example to illustrate how whatever we have extracted so far and the relationships among different classes, how that can be captured in terms of a use case diagram. It becomes very, it will become very clear to you now that these all different actors are independent classes according to the hierarchy and so on. And these use cases are basically actions, that is, they will be finally, in the final design, they will correspond to being coded in terms of certain member functions. Now, those classes are not shown here. The leaf classes are not shown here because we are trying to, the use case is primarily in terms of the external users. That's an overall specification. And leave, between the employees and the leave is an internal concept of the system, whereas employees will actually have to deal with the system, the leave management system. So that is the view that we are providing right here. So let me stop here before I formally start discussing the UML and see if you have been following the basic modeling of the specification through the process of analysis that we have performed so far. We have from that English description, now we have come to a much more details. We know the classes, we know their hierarchy. The hierarchy has been balanced. We know their attributes. We know their required actions. We know their relationships, collaborations, and we know the typical use cases which we'll have to satisfy. Any questions, friends? No?
Sir?
Yes, please.
Sir, do you have any more examples? preferably a bit short regarding the LMS which you showed us.
Bit short in the sense.
Big shot? No, no. I am asking for examples.
So LMS itself is an example, right?
So I'm asking for. Do you have any more examples for those,
Yes, yes.
or some source which we can look?
Uh, well, that you'll have to search. I have examples that I have created. So I have about 4 or 5 different system specifications that I've created. I can share some of them with you. We have on story management system, we have hire car management system, we have postal management system. Uh, so that there are quite a few such specifications. And I mean, don't worry, you'll soon get one such specification to do that exercise as an assignment. Yeah.
Yes,
But
sir.
typically, if you I mean, all those I mean, over the past couple of years, all those we have created. Not all of that are totally created by me. It's been a collaboration between me and the different TAs who have worked for this course. And we have created that because it's not very easy to get a compact specification and kind of the corresponding UML and so on the net, because most often these are internal documents of the companies. Right. So what you get are piecemeal information about different situations to be modeled. But I mean, at least I could not find such compact ones on the net. Maybe you may be able to find them. Let us know. So instead, what we have done, we have created several such example system specification, which students over the years have used to do their practice. Okay? But as such, if you look at the complexity and size of the specification, this is kind of the small. I mean, this is kind of a really tiny one. You cannot really make it smaller or simpler than this, because then the basic flavor of the challenge is go away. The whole challenge, remind you, in the analysis and design and in engineering, is the complexity of the things. So actually, in real terms, the systems are far more complex than what we are showing here. Okay.
Yes, sir.
Any other question? Okay. Then let me continue. So you have just got a glimpse of what UML diagram looks like. I'm very sorry that that diagram is wrong. I'll correct that and give you before I share. So UML stands for Unified Modeling Language. Right? So this has come up over several decades as a notation for system analysis and design. Right? Now, why do you need such a notation? There are a couple of reasons. One is this is a standard. So, for example, if you write a code in C++, you are following the C++ standard, which means that it can work on across different platforms. You send that code to someone else. Whatever you have written is exactly understood by that person and so on. But over several years, system analysis and design used to be done in terms of natural language descriptions and drawings, whatever way people wanted to do, and so on. So, which makes it on one side, it makes it verbose, it makes it ambiguous, and it makes it very difficult to share with others, because you may be using a term to mean something, and the reader may be understanding something else. So UML has settled to be a to be a standard which helps a designer or developer to capture the artifacts of your design. And it is mostly graphical in nature. Rather, I should say that it is graphical diagrams with annotations, where the graphical diagram or different elements used in that diagram have a very well-defined semantics in the standard. So if you write UML in a certain UML diagram and you send it to someone else, there is only one unique, unambiguous way to interpret it. So that eliminates the issues of inconsistency and brings in accuracy. It minimizes imprecision and so on. And this is a major factor. Facilitates robust communication within teams and with clients. So it provides a user with an expressive modeling language. This can be used for specification initially, then construction, visualization, documentation, and so on. And don't think that UML is only just a drawing tool. It's basically a design system which has a formal language inside. So it provides the user with ready-to-use core concepts. For example, there are a lot of concepts, like here itself we have up to as much we have discussed in the use case diagram, we have seen that the availability of the specialization concept, inclusion concept, extension concept, action concepts, and so on. So those are already available. But the nice thing about UML is you can extend and provide specialized expression mechanisms. And with that, UML provides a formal basis for understanding the model. So UML is kind of a development of concepts like collaborations, like design patterns, and so on. And the good thing is that UML integrates very well with the best practices in the industry. So UML also has been evolving. If I just show you, this is the evolution of the UML over about 20 years. And so initially there were a lot of attempts to do unified method of modeling that was kind of fragmented, and these are different methods that came in. And at a certain point, the primary proponents, Butch, Rambach, and Jacobson, in the mid-90s, joined Rational Software Corporation. It was a strong company like that. And they all had certain modeling framework. So they collaborated to meld their respective methodologies to create the first version of UML, which was then registered with Object Management Group, OMG, in 97 and adopted as a standard. So OMG manages that. And then from fragmentation to, you had the first creation of UML, unification. Then it took about a decade to come up with a standardization, UML 1.3 primarily. And then about another decade for industrialization, which means that it was adopted in the industry, and industry best practices were brought into the framework of UML and so on. So UML is a evolving process, and therefore it does a two-way traffic of imbibing the best practices that are current in the industry in one side, and other side is to influence the best practices as the use of UML. Right? So overall, UML does not prescribe any certain process. It does not say that you have to do like waterfall, or you have to do agile model, or something. You can do any process as well. It does not prescribe any specific tools to model or any specific guideline or a certain programming language. So it has a very balanced choice to represent the concepts as multiple level of details with a dedicated goal of remaining open. So openness is a big thing. So that's basically what UML is all about. Now, before what is the time? I think we'll start discussing the UML diagrams from tomorrow. It's already time. If there is any quick question, I can take that. It's already 12. Any questions? No. Okay then. Thank you very much, friends. We meet tomorrow again and continue our discussion on the UML diagrams. Thank you.